What's up, amigos? Today we have the aerodynamics of a crab. So imagine a crab just standing there in the middle of an ocean, and the flow is going from left to right, and we have the vorticity plotted here. And it's really cool. We can see that the roll up around the entire crab makes this effectively like a vortex ring. That's pretty cool when you think about it. A object like this is making a vortex ring, and then in the core, you see almost no vorticity until you go downstream, and then it starts to break down. I should mention as well, these are X-planes going downstream of the crab, starting from about midway over it, and then extending all the way down by like about 2 crab lengths. And now we have 3 Y-planes going from the crab's claws through the middle of the crab's body and also the back, like just behind the legs, so it's on the very tip of the back legs. And even though the back legs they're not that big, like they're just 2 small cylinders, they do create a massive wake because of how they're angled. And they're not very streamlined to begin with. So even though they're very small, there's still a massive wake coming off of each one of those. The claws have quite a large wake as well, and then the body itself is big, but considering that the legs have such a big wake, the body's doing pretty well comparatively speaking. And then they all break down relatively similarly downstream. Now we have a Z-plane going through pretty much the middle of the crab, and it's really cool. First of all, we can see that the wake is not symmetric, so the wake behind the top half, so like the legs part, that's significantly greater than around the claws. The claw wake seems to get sucked into like the body's wake quite a lot, and you can see that there's little pockets of slightly faster moving flow in around its claws and behind its rear legs a little bit, but then after that it becomes a little bit more homogeneous, particularly around the back of the back legs. And now we have that exact same plane, but now we see the vorticity. And a few things that are interesting. First of all, there's around the entire crab, there's like this massive vortex, like this vorticity that's rolling up. Secondly, around the rear legs, there's not much vorticity. So I've clipped this so that we can only see above 10 1 seconds, which means the small scale stuff we're not seeing. So that means that the vorticity around the rear legs is very low. And that's likely because there's such slow flow around that area that it doesn't have much energy to create vorticity from the surface. And also the flow around this area is moving in a not in a free stream velocity direction, it's just going meandering around and around. So there's no real coherence to that flow there, which indicates that you wouldn't get much vorticity anyway. However, because this crab is pretty much like 8 cylinders with a ball on top and then 2 prongs coming out the front, it is very unaerodynamic, and even when it's swimming, you can see when it swims around, you can see some videos on YouTube, they look fairly clumsy, even though they do somehow get around. They're not as efficient as fishes, obviously. So that's the information. Make sure to like, subscribe, and if you want to get better at CFD yourself, check out our courses in the link description. And if you want to get better at theory as well, check out those courses as well in the description. And I'll see you in the next session. Peace out, amigos.